Yeah, so I was talking about Kaggle. So make sure you create an account with Kaggle.com here. And what you're going to see with Kaggle.com is that it is actually a community worldwide for data professionals. So it's actually a very useful platform where you will find data sets. So like here we want to use data sets, you find them on Kaggle. You can also find code examples, data. You'll actually find discussions. I like these discussions. Like a good example, how do you get started? Maybe you have some question answer, some competition, and so many other ones. So you'll always find them on Kaggle.com. It's a very nice platform, even for you to learn on sometimes. Maybe you want to do some Python programming. Maybe you want to do machine learning, Pandas, visualization, SQL. So it's actually a very nice platform for data professionals. I wanted you to create an account with them because basically today we wanted to see how we can download datasets from Kaggle. So alternatively, as I've mentioned, Kaggle is worldwide, but here in Africa, we also have a platform called Zindi.Africa. Let me share also this one. Zindi. Okay, my audio is very low. Okay. So let me, okay. I hope you can hear me now. That's confirmed. So there is another community, striker community in Africa called Zindi. And Zindi is one of the largest network for data scientists and AI builders in Africa. Okay, so you'll find more than 75,000 data and AI practitioners in this platform. Okay, so I want to share this link with you. So definitely, I'm sure if you have these two accounts, then you will be actually joining two of the biggest communities for data professionals. So the first one I've mentioned is Kaggle.com. You actually go through it and see how effective it is. And also Zindi Africa, and this is basically a community that is specifically there to solve problems that are being experienced by Africans using data. So it's actually sponsored by Microsoft, Google, Amazon. So it's actually a good something that is good for as an individual, or maybe if you have a business. But for now, I'll just wish you join as an individual for now. But if you're actually joining as a team, then you can also create it with a business profile. So this Zindi is very nice because it gives you an opportunity to compete. So if you go to competitions in Zindi, that is, I still wait for other students to join. So I'm waiting for other students to join. I'm talking about Zindi. There are some challenges you'll find on Zindi that you can actually compete and get some bonus points or some cash prizes. Alternatively, I think it has opened, like there is this challenge where we want to use data to solve this problem here. And definitely here you're helping the entire Africa. And the competition is 24 days left. And if you actually become a winner in this challenge, you might get 15,000 USD. There is another competition where you want to help South Africans by mapping floods in South Africa. Okay, so this is almost closed. It's only remaining with 3 days, and I'm sure the winners are going to be awarded 10,000 USD. You also have this one where we are helping the entire Africa in this kind of a challenge. Here we are helping West Africa. Here we are helping Cape Verde. and so many other challenges. And I hope we can see that we even have, okay, this was completed 2 years ago, but it's actually a challenge that we was there to hack the Mara hackathon. And the winners, I'm sure they got 100,000 USB. That is close to more than 10 million. So if you are in this community, I'm not saying that you just join to get some cash prizes, because it's a competition, definitely, but it will actually give you an overview of the kind of challenges that you might be helping using data. So definitely, if you join, we have some challenges where you get some points and some challenges where you can get some cash prizes. So it's a very nice platform, give you some highlights on some of the problems that are being experienced by Africans. So for example, if you look at this one where we want to help South Africans map their flooding. So these are the kind of challenges that we have that can be solved using data. So a good challenge is, can you identify where and when an urban flash happened in South Africa? So this is very useful. They normally give you a very nice description, the project. They're also doing some evaluation, some prizes, and so on and so forth. So what is really interesting about this platform, and I really like it a lot, it's because you're actually now getting to know what you'll be doing in the market as a data professional, either being a data scientist or a data analyst. So I hope now you have these two accounts. So for today, specifically, I wanted you to have an account with Kaggle, because Kaggle now have a competition that are hosted worldwide. So a good example is this one that was hosted 2 months ago for some AI mathematical Olympiad and so many other ones. So what will actually be interesting about these challenges, as I've been mentioning, is that now you're able to see the kind of problems that you'll be solving to the community, let's say in Africa or around the world, using data, okay? So some of the challenges, you can do them just to get some knowledge. Others, you can do them to get some cash prizes. And I think this is something now you can be doing just to build your confidence and your problem-solving skills using data. So you have competitions. They even have some models that you can use. I'm sure you've heard about DeepSeek. It's already a model that is hosted on Kaggle, so you can always use it from here. They have some discussion, like I've mentioned, where you can learn, and so many other more. For example, we even have some user ranking. So we have those people we call the Kaggle. In around the world, currently, we have 357 Kaggle Grandmasters. We have 2,000 Kaggle Masters, 10,000 Kaggle Experts, 67,000 contributors, and so many other ones. So just getting recognition from Kaggle, it's actually something that will actually build you in the community. So we have some documentation and so on and so forth. So these are where now the community is. If you want some data sets, sorry, I think they were the data sets. So if you want some data sets, they are all here. For example, these are the trending data sets that they have so far, like deodorant data set. We have data set to do with music. So if you're someone from the entertainment industry and you want to analyze the Spotify data set, you'll always find it here for free. We have data sets in business. So you're someone working in a business setup and you have some knowledge to do with data science. They can give you a sample supermarket sales data set that you can actually learn to analyze, so that now if you have, like, let's say you have a project to do with analyzing supermarket sales data set, now you're ready to do it. If you're doing banking and finance, there is a sample data set that is already hosted here for free, and so on and so forth. There's for business. For those people who are doing computer science, they have their data sets here. Later, we'll be doing machine learning, and we'll be talking about classification. So all this data are here, and so many other ones. If you search, maybe you're working in agriculture. Let's say you're working in agriculture. Maybe you're working in an agri-tech field, and you want to see how can I use data to solve problem in agri-tech. So you'll always find some insights here by actually using this kind of data. Let's say you're working on education setup and so many other industries. You're working on marketing, you're working on with the government, and so on and so forth. So I hope by now at least you have an account with Kaggle. So definitely I'm ready to start. I was just talking about these two very important community that you as a data professional, you should be part of. So to start us off today, so basically today we want to proceed with exploratory data analysis. And remember, like we had mentioned, EDA was specifically a course that we wrote so that now you're able to work with data. So we said that for you to effectively work on EDA projects, then you need some tools. So the first tool was Python. The other tool that we did was NumPy. Specifically, you have to be good in NumPy arrays. And yesterday we talked about Pandas. So today we want to see how you can now make these tools into practice by actually doing what we call data cleaning, data wrangling, data transformation, and aggregation, now using Pandas and NumPy. So introduction, you're actually saying that data cleaning, wrangling, transformation, and aggregation are actually essential process in data analysis and data science because they ensure that the raw data that you collect in the environment is structured, it is complete and meaningful before conducting further exploration or applying machine learning model. So I want to give you an example. You are a data analyst. So you've gone to the environment, the field, and collected some raw data. So as a data professional, you need a way to make the data to be structured, complete, and meaningful, so that now you can perform further exploration like data visualization. Or if you're a data scientist, you can actually apply the complete data into a machine learning model so that now you can generate some insights. So this lesson will actually cover the key data preparation techniques using Pandas and NumPy, which are widely used libraries for data manipulation in Python. So just to repeat, for you to be very effective on all this process, then you need some knowledge to do with Pandas and NumPy. So these are the requirements. These are the requirements. At least for this program to be effective to you, you need some knowledge of Python programming, because you're going to notice that Pandas and NumPy are actually Python tools, okay? So we'll be talking about concepts of data analysis, and then we'll also be talking about the importance of a clean data and to get an accurate insight, okay? So for you to start this process, we normally start from data selection. So data selection is something we also call data mining. It's actually the process where we actually capture information from the environment so that now we can start the analysis. So for this lesson, we will actually use real-world data sets from either Kaggle, Zindi Africa, or the University of California dataset repository. And the dataset that you're going to use today is what we call the housing price dataset. It's one of the most famous ones out there. And you're going to see that this housing price dataset contains various attributes related to real estate. For example, pricing, location, house features, or sales history. So today we want to move as real estate agents and want to see the kind of analysis we can do to a real estate dataset. And a good example is what we call the housing price dataset. And this dataset is actually hosted on Kaggle. So before we even proceed, I want to share with you the link so that now you should be downloading the dataset and now uploading them to your notebook. So I'm sharing this link, share with you this link. So this is the link to the dataset. So I want you to be downloading them earlier. Let me share it on the chat, sorry. So I'm sharing this dataset on the chat, link to the dataset on the chat. So if you click on that link, it will take you direct to Kaggle. It will direct you to kaggle.com. And you're going to see that these housing prices was actually a competition that was done previously. So for you to get the data set, you'll have to join the competition and then you'll actually download the data set from here. Let me just confirm. So you'll go to data. So after you've joined the competition, you'll go to data and then you're going to download these two information. Number one, I want you to download the data description.txt, this one here. And also, I want you to download the actual data set from here, which is here, okay? Right here. So this is actually a long process. I had already hosted the data set on my Google Drive as well. So let me know whether you're able to access my Google Drive. I'm sharing the link here. That is the link to my Google Drive where I have posted the data set. So if you press the link here, let me do it again. If you open that link, we are going to open the data set. It's actually a CSV data. It's actually a CSV data. I hope you can see here. So what I just want you to do is to download it. I hope you should download. And now, just to ensure you have it on your system. So this is the data set that you want to use today, the housing data set, right? So ensure you have it, the housing data set. I'm sure this is the easier one. Just copy this link that I've uploaded on the chat. Okay, let me pardon, Kada. So I'm saying that for this project today, we want to work with a real world data set. And the data set that we are using is already hosted on Kaggle, but you're going to notice that for now, it will actually be a process downloading data from Kaggle. So this data set, I have hosted it in this link here. I don't know whether you can access it. I don't know whether you're able to access it. So if you paste this data set to your browser, this link, sorry, to your browser, is it opening this data set here? So that now you should be downloading it from here. Oh, Google Drive access denied. So let me just confirm what could be the issue. Perfect. Let me grant you access, Nafiu. Sorry, I restricted the access, but now I'm granting you the access. Sorry for that one. Now anyone with the link should be able to access the data set. So I'm sharing the link again, that one. So I've shared the link. Now let me know whether if you click the link on your browser here, you are able to open up this data set. So let's start from there so that now it's ready. We'll be ready now for the data cleaning process. Perfect. I can see Now you're able to have it. So if you're able to open the data set, then just go ahead and download it. Download it using this icon here. So if you just click on this icon, definitely the data set will be downloaded to your system. So we'll now be talking about how do you load this data to your project. So it's actually a CSV data. So anyone who is not with me up to there, before we even proceed, at least you have the data. So this is where we start. Yeah, so Gloria, you're asking how do I access the data from Kaggle? So if you want it direct from Kaggle, then there is this link here. But for now, I think it will be quite challenging. So just to make the process easier for you, I would hope you work with the link to the Google Drive here for now. But I think later we'll be talking about how do you go and access data from Kaggle, because it's a very important skill to know how to go to the field and capture information, okay? So after capturing information, this is what we'll be calling data mining. You're actually mining data. Remember we say that data is considered to be like an oil. So you go to the environment and mine the data. So that is what we'll be calling data mining. There are so many ways of mining data. We'll be talking about the ETL tools. But for now, I want you to imagine you've been given data and you want to start your analysis. How do you go about it? So this is the first process. You need to have the data. This could be a school data. It could be a finance data. It could be an hospital data, a supermarket data, climate data, and so on and so forth. It could be data that is related to the government, okay? So now where do you start from here? If you have this data, what do you do from here? I hope you have it. Please, if you don't, let me know. If you don't, let me know. So I hope you have it. Okay, so I hope you have it. So in our today's class, because we'll not focus much on data mining, we'll have a lesson for that one. So in our today's class, I want you to imagine you have the data here. This is the data you've been given, okay? So going back to the notes we are now talking about, we will start by actually learning how do you load the data to your project and how do you start your data exploration. And we're going to see that the first step in data analysis or data science project is loading the data and exploring the data structure. Okay, so what we'll be involving here is you'll be learning how do you read information from different sources. So the data can be a CSV data, like the one you're having here is a CSV data. Sometimes you can be working with an Excel data, or you can be loading data from a database. So these are very important topics so that now you're able to read data from different sources. Then after reading the data, you will be checking the data structure. So this could be checking the number of rows and columns that we have in the data, okay? You could be displaying sample records so that you understand the data distribution. Okay, you might also want to identify whether you have some duplicate entries, which could actually skew your results. So therefore, in case you'll be actually getting some duplicate records, you could actually remove them from the dataset. And then finally, you could be generating some statistical summary so that you identify potential issues like outliers or missing values. So these are very important aspects. So this is the first process that we are going to learn today. How do you load and how do you explore data. A good example like this one here. Now from there, we are being told that by performing these steps, we will gain an initial understanding of the dataset's quality or any potential inconsistencies. How do you know whether the data is clean if you don't explore it? So you'll have to load it and perform some initial exploration so that now you can determine whether we are actually dealing with the right data set and the data that is not having any inconsistency. Now, the second step we are going to talk about today is now, in case there were some missing records in the data, how do you handle them? Okay. So because you're going to notice that missing data, it's a very common problem, especially in real world data set. Okay. So to handle this one, you're going to learn how to identify the columns with the missing values and assessing their impact. Okay. You're going to learn how to drop columns or rows with excessive missing values if they are not useful. Okay. How do you fill the missing numerical values using some statistical technique such as the mean, the median, or the mode? Or how do you replace the missing categorical values in the most frequent category, such as unknown? So this is something you're going to learn. How do you handle missing values? Now from there, you might want to do what we call data transformation. And we're going to say that data transformation is the process of converting raw data into suitable format for analysis. So for you to do data transformation, there are some steps that you follow. The first one could be converting the data types, such as changing numerical values stored as text into proper numerical format. So you might find that someone stored a numerical value as text. So you need to properly transform that one. Or maybe you can be transforming date columns into standardized format for time-based analysis, what we'll be calling time series analysis. Okay? Yes, Anita, let me share with you the link. This is the link. There's a link now. You want the link? Sharing right here again. Perfect. So I've shared the link again for you. So you're actually going through what is data transformation. So after actually transforming the date columns, we could also be performing what we call scaling numerical values to bring them into a common range, which is especially useful in machine learning models. You might have data that is ranging between 1 and 1 million. So you might want to scale them into 1 in a scale of 1 to 10. Okay? And then we'll also be talking about normalizing numerical data so that we remove the unit dependencies. So you're going to see that this transformation normally enhances datasets usability and improves the accuracy of our analytical models. Okay, very important one. The fourth step in data preprocessing is what we call feature engineering. And feature engineering involves creating new features from existing ones to improve data quality. So this step might include calculating new variables, such as house age by subtracting the construction year and the current year. You might want to know how old is an house, okay? Because a certain potential tenant might want to know the age of an house. So if you want to do this one, then you need to create a new column. So what we'll be calling new variables by basically subtracting the year that the house was constructed with the current year. So this is what we call feature engineering. It's actually creating new features, okay? So you could also be performing binning continuous variables into categories. We'll be talking about that one. And sometimes you might want to combine multiple columns to generate interaction features, okay? For example, total living area by summing up the basement floor and the floor space. So we're going to see that feature engineering helps uncover hidden patterns in the data, so making it suitable for predictive modeling. And then finally, at step 5, we also have what we call data wrangling and data aggregation. So we're going to see that data wrangling involves restructuring and organizing data so that we make it more useful. So this process could include grouping categorical variables to summarize key insight, or you can be working with what we'll be later calling pivot tables, or you could be merging different data sets. So data aggregation allows summarizing a very large data set efficiently, helping analysts extract meaningful insights. And then I think now the last step in data preprocessing is what we call now, is now when we export now the cleaned data. This process is very crucial, where we are saying that once the data has been cleaned, properly transformed, properly feature engineered, so it is now crucial to save the process version for further use. So this process could include saving the clean data into a separate CSV file, or ensuring that the formatting and the data integrity is maintained for the future use. So maybe now you want to go ahead and do your data visualization. What we'll be now doing next week, we should be visualizing a properly cleaned and transformed data. So what we'll be doing today, we're going to learn how to clean, transform, feature engineer, remove missing values, and then later we export it so that now we can perform further analysis. So exporting allows data analysts or data scientists to reuse the clean data without repeating the pre-processing steps. So I can say that in conclusion, before now we do the practices, data cleaning and transformation are fundamental steps in data science and data analytics. So by applying this process, now we can remove inconsistencies and missing values. We can transform and standardize data for analysis. We can engineer new features to enhance the predictive power, or we can also aggregate data for meaningful insights. So therefore, these skills are very crucial for any data-driven role, ensuring that the data set used for analysis is reliable and accurate. So there is a saying that goes, if you provide garbage, you get garbage. So normally most people say garbage in, garbage out. So as a data scientist, you don't want to provide garbage to your analysis, because definitely you're going to get garbage. You want to provide data that is reliable and accurate for analysis. So let's try to do this process. And I hope you've downloaded the data set that I have provided, so that now we are ready to start the analysis. So if you're there, I want you to click on this link. So I want you to click on this link here. So click on this link. It will definitely open up a Google Colab file that will now help us perform all this operation that I've been talking about. Then from there, next week, definitely we'll be now talking about data visualization using Matplotlib. So I hope you have this Colab. If you don't, I'm sharing the Colab link on the link. So if you don't have the link, I've already shared that one for you. So I want you to open up this column. And then also, I want you to open a separate notebook that we can use to perform our analysis. So let's open up a new notebook. I want to close these so many tabs that I have. I want to close them so that now we remain with few tabs. I don't need YouTube. I need this one here. Let me put it here. Then from here, I want you to create a new notebook called Google Colab, so that now we can do the practices. As usual, the more you do the practice, the better you master these very important skills. So I want you to create a new notebook as usual. I want you to create a new notebook from Google Colab, so that now we can do the class practices together. So before we even start, I want you to label this notebook data. So all those operations is what we call data pre-processing. Then we'll be calling it class practice. So data pre-processing class practice. Okay, so make sure you have the notebook for your class practices. And it's also good to have this notebook that will be guiding us. It will be guiding us. It will be guiding us on what to do from here. So in this notebook, we want to do cleaning, wrangling, transformation, aggregation. So we will actually, this actually will be helping us in preparing data for meaningful insight by actually handling missing values, removing inconsistencies, and structuring data for further analysis. So in this lesson, it is very important to mention that we will use Pandas and NumPy to demonstrate this process in a real-world data set from Kaggle. So the data selection, I've actually selected this data for you, but in your project, you can be working with any different kind of data, depending on your field. Maybe you can be working with the finance data or any other data out there. So for this lesson, let's work with what we call the house pricing data. This data, I downloaded it from Kaggle, and you're going to see that it contains real estate data with various attributes, such as various attributes about housing. For example, we have the location, the size of the house, the price of the house, and so on and so forth. So make sure you've downloaded the dataset. I've shared the link. Which is actually in my Google Drive. So step one, we are talking about loading and exploring data. So let's start from there. So today, we are doing what we call data pre-processing, a very important step, which ensures, it ensures that data is of good quality without inconsistencies, without duplicates, without missing values, without outliers, We're talking about them without outliers. Which we are actually saying that if you're actually analyzing data that is inconsistent, you are analyzing data that having duplicate, you might actually get wrong insights to the stakeholders. So it's actually good before you do any analysis, you first pre-process the data that you have. So you want to start with step one. For you to do any data pre-processing, number one, you need to have some knowledge. I think I should share this one with you. You need to have some knowledge to do with how do you first load data to your project. So that is where you're going to start. So number one, loading data set. So let me even say loading a raw data set. So a raw data set is the data from the environment. Okay. So to mention this one, I can say that we might have different formats of data to load. Okay, so I can even say that if you actually if you have a data that is in form of CSV, then we normally use this function called pandas dot read underscore CSV. Then this is actually a function, and then definitely you'll provide the link to the data set. Okay. So alternatively, maybe you're not having a CSV data. At some point, you might be dealing with an Excel data. So you might actually work with a spreadsheet. And in this case, then Pandas will give you a function called read underscore Excel. And then now you pass the link. I think these two are the most common, but at some point you might be reading JSON data and so on and so forth. So let's start together. We have a CSV data that we have downloaded. So it's in our downloads here. I hope you can see. The data set is already in the downloads. So what I want to do first, please take note that we want to go to the files. I hope you can see. I am loading the files of my Google Colab here. Yes, so Google Colab already has NumPy and Pandas installed. Like we had mentioned, Google Colab have some pre-installed libraries for data science and data analysis. So they're already pre-installed. So in our step one, before we load any data, we need to have the data in our project here. So what I want you to do, I want you to open the files. Open the files. So you normally have to wait because you're actually working with the internet. So you'll have to wait until you are given something like a storage here. So you see, we are actually initializing that backend from Google, and you know that you have actually loaded your files when you see the disk here. So this one depends on the internet here. I hope you can see that one. So if you don't see the disk here, then we are still loading, we are still initializing your files. Okay, so make sure you see that you have the disk here. Like for example, mine, I have 78.72 gigabytes available. So what I want you to do, I want you to click on upload. Okay, so there is this first option here. I hope you can see the first option here, this one here. So this is the option where now we can upload our data set to this project. So you have to remember where you downloaded your data set. Like mine, it's on the download, okay? It's on the downloads. So make sure you click on the icon to upload, and then automatically you should be actually having your file system here, okay? Then it's on our downloads, and then it is actually the housing data set, and then you open. So there are some warnings that you are being told, but you just ignore by pressing OK. So please ensure that you are able to see your housing data set loaded in your files. So if you're not able to see that one, please let me know. Okay, so I'm waiting for that one. So if I may repeat the process, this is where we started. You click on your files until you see the disk in your file. Now you know you are actually inside your file system. And then now you upload the file here, and then you'll have to see the data set here. If you don't see the data set here, then perhaps you have not loaded the data successfully. So in case you have any challenge, I want to see them. Yes, so Nkabla, you're asking whether I've installed NumPy and Pandas. So they are pre-installed. So they are already in our project. They are pre-installed. And that is one beauty about Google Colab, because you said it comes with some pre-installed libraries. So I hope you have this data here. Let's first maintain it here. Now let's go back to our notes. Now we are being told that now, because we have uploaded the data set here and we want to read it in our project, these are the procedure we do. Number one, we'll have to import NumPy and Pandas, because we're using the NumPy and Pandas. And just to confirm with you, Kaggle, is that if you try and load this code cell here, just click on this one here. I hope you can see that you have a green light. You're being told that you have imported Pandas, you have imported NumPy. So this means that successfully they are installed in your If you didn't have them, then you would have gotten installation issues. So I hope you have it. And I also hope that you have imported Pandas and you have imported NumPy. So now for us to read this data set, because that is the first process, let's check here. We'll have to use read CSV, okay? So we're actually using the function. Okay, let me just copy it so that it makes sense. Yeah. So let me just copy it here and paste it here. So this is the function. This is the function here. Okay. So because this data is made of several columns, it's a data frame. That's why we are calling it DF. You can call it any name. It's a variable that we are using to store our data here. Okay. Now, where is the data located? Because if I try to run this link now, I'll get an error. I'll be told that the link that I've provided here is not found. Okay, it's not found. There is no file called train.csv. So how do I get this file here? So what I want you to do now, I want you to copy the three dots, the options here. The options here. So click on these options and then copy the path. So if you're copying the path, then definitely you're copying the location of this file in your Google Colab. So copy this path and then remove this train.csv because it's not available. And then you can now paste the link. So this is the path. You have gone to the content of our Google Colab, and now we have the housing data set there. So if you run this one, if you don't get an error, then it means that this operation, we've loaded the data set successfully, and then we've stored this data set in this variable called DF, or data frame. Okay, so make sure you have this one. Now, if this is successfully done, you can now close your files here, so that now you have a space. So let me share this one with you in case you get an issue. So anyone with an issue up to there? Anyone with an issue so far up to there? So I've said this housing data must be inside your, and then you go ahead and copy the path, and then you paste it here. And because this data set is a CSV data, then we'll have to use the read_CSV function. If it was an Excel data, then we should have read the Excel data. Then here we provide the link, which is actually the path. Let me even say the link. It could be the link or the path to the data set. Okay. So now the path is now, by clicking on this option, you can actually copy the path and then you paste it here as a string. Remember, it's a string. It's made of sequence of characters, so it's a string. So therefore, you have to provide the double quotation. And successfully, we've done step one. So we've actually read a raw data set. The next procedure is to now exploit, so that now you're able to understand the data set that you want to use. Okay? So now you're able to understand the data set that you want to use. So for that one to happen, we can call some functions. So the first function is when you want to display some basic information about our data sets. Let's copy that function in a new code cell. So in our data exploration, I might want to take the data that I've read in this variable and check the information about the data set. So that is what we call df.info. So if you run this one, then it will provide us with detailed information about the data set that we want to analyze here. That is what we call df.info, or the data set name, and then it generates the info. So we are being told here that we have a total of how many? So it will actually be giving us all the columns in our data set and their data types. For example, we're being told we have 3 columns that are float, 35 columns that are integers, and this is very interesting to note, 43 columns that are objects. So remember, in Pandas, strings are referred to as objects. Strings are referred to as objects, okay? Strings are referred to as objects. So let's talk about floats, integers, and objects here, so that you understand what's happening here. Let's do it very fast. So in data science, in data science or data analytics, in data science or data analytics, float data, normally they are called float 64 data, we will be calling them continuous data. So they are numerical data with fractions. So numerical data with fractions or decimals, okay? So it's good for me to mention this one. In data science, the float data, I will be calling them continuous data. So they are actually numerical data with decimal. So they normally draw a curve. So if you want to draw them in a graph, they normally draw a curve at some point. Moving further, we also have int 64. So this one will be calling them discrete. So we'll be calling them discrete data. And you're going to see that discrete data are numerical data as whole numbers. So they are used for counting. So they are mainly used for counting, indexing, and so on and so forth. I think these ones are mainly used for measurements, arithmetics, like you can add them, you can subtract them, and so many other ones. So I can just say ETC. We have so many operations you can work with continuous data. So we have float 64 that are continuous, int 64 that are discrete. This could even be IDs, and so on. And I can even say ETC, so you can research more. And then finally, we have objects. So that is something I really wanted you to see. We also have objects. Please take note. Objects, we will be calling them categorical. We'll be calling them categorical data. So we are going to see that these are data that is represented as text. Okay, e.g. So there are data that is represented as text. Sorry. For example, you can have names, people's name. Maybe you can have an location, etc. Any data that is represented as text, we will be calling them objects. Okay. So if you just want to understand how this info works, is that here we have a total of 3 objects. So the objects that are 3 are this is what we call the fence, the type of the fence that surrounds the house, the miscellaneous features. What else? Oh, those are not floats. We only had 3. So floats we only had 3. Let me see the floats. So we had the garage, something. This was a float. Something else that was a float here was let me be very keen find out. And so many other ones. I think this is other one. So this one here. So you're going to see the dataset description so that we understand what this column means. Okay, what this column means, and so many other ones. And also we have integers that are 35 and objects that are 43. So it's good to note that one here. If you had date and time, they could have recorded and so on and so forth. So we're also being told that we have a total of 1,460 records, and each record we've indexed them starting from index 0 to 1,459. So each record can be indexed starting from index 0 all the way to index 1,459. And we're also being told that we have a total of 81 columns. So these are very good information we are getting from the data just by loading df.info. So that is a very important function there that you'll always be calling so that you get detailed information from your data set. So moving further, let me just check whether we have some questions. From here, moving further, any question? So that is what we call. So Anita, you are saying yours is giving you an error. I don't know which kind of an error is that one, but make sure you have copied this path correctly. You've copied this path correctly. And then you enter it as a string. So make sure you have them as a string here. And also to ensure that you're actually not getting an issue, ensure that the name of this file is exactly the name of this file here. So those could be the issues you can have. So if you're actually getting an issue, probably you can work with my code here. So if you just copy this code and you have this data, I think it should work successfully, okay? And then similar, if you're doing df.info, make sure that they are all in lowercase and you don't have any indentations here. make sure you don't have any indentation. Here is an issue that you might have. So you don't have any indentation similar to this one here, no indentation here. Those could be possible issues that you might check. It's still, if you're getting an error, you can still let us know.
Excuse me.
Okay. Hello?
Yes, can you hear me?
Yes, I can hear you.
My question is, when we are loading the data set, when
Yes.
we run it, are we supposed to see anything?
Or if you wanted to see it, that's a very good question. If you wanted to see the data, then you can just print it here. But I think that is what you're actually doing in the next phase. But if you wanted to see it before even getting the info, you can actually print the variables here. Okay? You'll be able to see it here.
Oh, okay.
But I think
My
you want to
question
do
was
it in our
just,
next, after getting, pardon?
my question was just if I'm supposed to see anything after writing that, loading the data set.
Oh, for now, you're not supposed to see anything. You're just supposed to see this green light here. Are you seeing this one here?
Yes.
This one here. If you're seeing this one here, then it means that you have read the data successfully. Are you seeing the information here?
Yes, yes. When I run that one, I'm seeing
Information, then it means that you read the data successfully. Now, if you want to start seeing the records, that is what we are going next. You can actually use this function to show the first few rows using the what we call df.head. Let's try this one, df head. So let's try this one and see whether we can see some rows. So try it on a new code cell. Try it on a new code cell. Sorry, I want to do it after this one. So if you want to see some few rows, you can actually work with the head function. Let's say I want to see the first 10 rows. Okay, the first 10 rows. It will actually display for you the first 10 rows. And I hope you're seeing that the first 10 rows we have from index 0 all the way to index 9. So these are a total of 10 rows and 81 columns. Okay? So that is actually how you're viewing them. So you can even say, I want to see the first 100 records. You're able to view that one right here. You can see that one from index 0 all the way to index 99. You are getting 100, the first 100 records. So alternatively, you can also have the tail. So df.tail, if you want to see the last record. Let's say I want to see the last 5 records. You can now see the last 5 records are actually from index 1455 to index 1459. So if you work with the head, you see the first rows. If you work with the tail, I can just say here, you can actually show the last rows. And then you just specify the number of rows that you want to view from the data that you have. So let me just copy this one and paste it for you here. Yeah, so like that one. So this is actually how you can view some few rows within your data set. Also, moving further, there's no any question because of time. You might also want to see whether there are some duplicates available. So let's check whether we have some duplicate available. So if you copy this code here and paste it here, so let's paste it here. Yeah, so you want to check whether we have some duplicate entries. So to get duplicate entries, you normally call a function called duplicated, then you do the sum. Okay, you actually sum the amount of records that have been duplicated. So if you run this one, you've been told here that you have a total of 0 rows that are duplicate. So now it means that this data, we don't have any duplicate record. It's very good to know that it's very good, important to check whether you have any duplicate rows. For you to get this one, you just have to call the duplicated dot sum. So you take your data frame, you call the duplicated function, and then you do the summation, you sum them up. And for this data, we have 0. If it could be a different data set, it will tell you how many rows have been repeated, so that now you can remove them. So let me share this one with you. And before doing even statistics, we can also check whether we have any empty record. It's good to check. Any empty record, it's good to check. So I think we can just do it here on a new console. So I can just say checking missing records. Missing records. So this is still what we call data exploration. You've loaded your data, so you're doing some exploration. So what I can say, I can call them missing. So missing is when you say df dot. So there's a function called, is null, that function. So if you call this function called is null, so is null means that is there any record that is missing? So null talks about something that is empty. So if you say df.is null, then you do the sum, you're going to get the number of records that have been repeated. So if I want to see the number of missing rows, then I just need to print the missing here. So for the duplicated, we didn't have any. Maybe we can confirm whether we have any missing records. So if I run this one here, then you can see that there are some records which are missing. For example, this load footage, we have a total of 259 missing records, but I think we'll be checking it later as we proceed. So I'm just showing you that one there. So moving further, can you perform any statistical summary? Can you perform any statistical summary? You want to get the mean, the mode, the median. So you can actually do that one here by actually calling a function called describe. So you're doing what we call descriptive statistics. So we have descriptive statistics is when you want to get something like the mean, the mode, the median. So in Pandas, we've been provided with a function called describe. So there's a function called describe. So if you call this function, then you are actually performing descriptive statistics. You want to get the mean, the mode, the median. So that's why when you run this piece of code, then it's actually giving us the count, the mean, the standard deviation, minimum, the lower percentile, the midpoint, the upper percentile, the maximum, and so on and so forth. So this is what we call descriptive statistics. Later, we'll be talking about inferential statistics. So later we'll be talking about inferential statistics. Inferential statistics by actually testing hypothesis. So testing hypothesis at some point. So we have two types of statistics. We have descriptive one, when you want to get some facts like the mean, mode, median, or you can also perform inferential statistics when you want to test some hypothesis within your data. So this is something you're going to do later. Just wanted to show you how to explore data within your data set. So I'll share that one with you. You can actually find it out later. So in the next module, because of time, we have like 10 minutes. So the explanation is that the info provides an overview of the number of columns, their data types, and the missing value. The head displays the first rows. The duplicated.sum helps identify duplicate row records, which can cause bias in analysis, and then describe provide summary statistic of numerical columns, helping us to understand the distribution of data. So I have seen a very good question. Do we have to cram this function? I can say definitely yes, but something good is that the more you practice on them, the more you'll be mastering them. So that in case you are actually working with any data, this is what you'll be doing. This is what you'll be starting with. You'll actually be checking the info, you'll be checking the head, you'll be checking whether you have duplicated records, you'll be checking statistical summary within your data. So that is the first process. So this is what we call loading. This is what we call loading and exploring data. So if you want to explore data, those are the functions that we'll be using later in our analysis. So number two, now how about when you want to handle missing values? I'm sure we have a lot, but for now, because of time, we just identify them, and then later we're going to see how to either drop them or fill them. Because of time, you're not do dropping and filling, but it's good to see how to count missing values. So let's start with this one. So this is now procedure number 2. So number 2, we are now talking about handling missing values. So to do this one, you can start by counting them. So counting, So counting the missing values. So to do the counting, just have to call this function. So the one I said, you want to just take your data frame, you check whether we have the null, we do the sum of the total null, and then we can sort them in a descending order. So if you run this code, you're being told that the column with so many empties is this one, which we call poll IQC, followed by miscellaneous features, followed by early, followed by fence, and so on and so forth. Okay, so these are the number of missing columns that we have. So if you want to start cleaning them, you'll be doing them in your data cleaning process. So in our next class now, we're talking about B, because of time, how do you drop the missing values? So you can decide to drop them, so you can check them out, or how do you fill the missing records? So you have two options. You can either drop or fill. So it depends with the operation you have. There are some data that you cannot afford to drop, so you'll have to figure out how to fill them. So we'll be having a class talking about how do you either drop missing records or how do you fill missing records. I want to share this one with you. I will be actually taking on them in our next class. So number three. So are we together? Number 3, because of time, I think you're here. You're still here. Anyone? Number 3 now. So you're talking about feature engineering. So all the explanation has been done here. So you want first have to identify the missing columns. You can decide to drop them, or you can decide to fill them. So we'll be talking about this one. So we go to data transformation. I will not do this one for today, but I'll mention it. It's a way to convert data from one data type to another. For example, this data, you want to convert it to a string. So you can call this function as type, then you convert it to a string. Or you have a date time data, like this one, the year that the house was actually built. So this data has to be in the right format of date and time. So for you to do this transformation, you can actually take your data frame, your pandas, you call a function called date and time, and then you pass the column here. You can also do what we call normalization and scaling. So if you are doing scaling, you can work with the minimax scalar, and you can also work with the standard scalar. So you're going to do this one in our machine learning classes, and you're going to differentiate between what is the minimax scalar and what is the standard scalar, and where do we apply them. So for feature engineering, it is where we want to create new features from the data. So let's say I want to create a new column called the house age. So for me to have the house age, I can actually take the difference between the year the house was sold, I minus the year the house was built, and I convert it into date and time, date year. Okay. So you can also be doing the binnings and continuous variables and so on and so forth. So basically, feature engineering is the process where we create new features from our dataset. And you're going to notice that it enhances dataset quality. You're also seeing that, so it will be helping us properly analyze our data and so on and so forth. So talking about data wrangling and aggregation, that's something we're going to do from next week. It is when you want to get, perform some aggregation, like you want to do some summation and so on and so forth. So for example, you want to get neighborhood prices. So this actually, you want to group data by their neighborhood, and then you get the price. Okay. And you can also, we'll be talking about pivot tables, where we want to view data in 3 dimensions. So we have the X, the Y, and the Z. And also in data wrangling, we'll be talking about how do you merge different data frames. I think all the explanations have been here. And then now, if you're done with all these 6 procedures, because of time, all these 5 procedures, you can now export your data into a new file. Okay, so for example, I want to imagine I've done all those data preprocessing techniques. I can definitely call this function. Let me just call it even here. Okay, it's what you call to CSV, and then you're going to get your cleaned data here. So if you run this code, then you'll get a new file exported here. I hope you can see. This was the original data, and this is now the cleaned one, but now we can use it in our further analysis. Maybe you want to use it in machine learning, or you want to use it in Tableau, or you want to use it in Microsoft Power BI, and so on and so forth. So basically, that is what we call data preprocessing, where I can say that in conclusion, data cleaning and data transformation is very important step for analysis. And using Pandas and NumPy, you can handle missing values, you can transform data types, you can engineer new features, and you can even aggregate, you can get aggregated insights. And later you're going to see that these techniques are crucial in real-world application, like the one you're doing on real estate prediction or even customer analysis. So I know I've rushed on the last 3, but we're going to do them in more details starting next week. So any question up to there? Any question up to there with data cleaning wrangling, transformation, aggregation, and so on and so forth. So for today, our main objective was actually for you to understand how do you handle missing value? What do we mean by data transformation? What do we mean by feature engineering? What do we mean by data wrangling and data aggregation? And how do you export a pre-processed data for further analysis? So any questions so far to there?
Hello.
Yes, hello?
Okay, I had a question, but I think I've understood halfway. So my question was when like you're doing this data transformation, filling missing values. So like
Yes.
it's the original Excel value being edited, or you're creating a new one?
Yeah, that's a very wonderful question. So it's the original one that you are editing, but now after now doing all those process, you can now convert it on a separate file. Okay, you can now generate it on a separate file. So now this file will contain all the changes that you've made. So now we are assuming that now this is a cleaned data without any missing values. It doesn't have any duplicate records. It is properly transformed, scaled, normalized, and feature engineered.
Okay, thank you.
And just, yes.
You have understood.
Oh, you've understood. That's good. Yeah.
Yes.
So just say all this process we are doing is what is done by what we call a data engineer. So a data engineer is someone who picks data from the environment, pre-process the data, and then clean it. So from here now you hand over this data to another person who is a data analyst or a data scientist. So the data scientist will now use this cleaned data to generate proper insights. I saw another question from yes, what if you find missing values or duplicate records? That's a very good question. So if you find them, you will have to remove them. Only that I've skipped those processes. For example, if you find some missing record, you see the first process is you first need to identify whether you have any missing data. Then if they are there, you can either decide, based on the stakeholder engagement, you can either decide to drop them by removing them completely, or you can decide to fill them. So we're going to do this one next week. We'll be talking about how do you fill columns that are numerical, or how do you fill columns that are categorical. So these are the two options you have. So you can drop them, or you can fill them. For duplicates, if they were there, you can also drop. There's a function called drop duplicates. Then it will definitely remove all the duplicate records that you've identified within your data. So I hope I've answered that one. Okay. So any other one? Okay, so if you heard about a role to do with data engineering, this is what they normally do. They mine data from an environment, they pre-process the data, and they hand over a cleaned data to another stakeholder who will now proceed with our further processing. So now this is what we call a data engineer. You are going to notice that at some point we normally have what we call data warehouses. So a data warehouse is where we store a cleaned data. So after pre-processing this data, we can decide to store this data in a data warehouse so that now a data analyst or a data scientist can now perform the further analysis. So the further analysis I'm talking about here could be machine learning to perform predictions. You could work with some tools like Power BI to do visualization, Tableau, and so on and so forth. So looks like now we don't have any other question. I know we've actually rushed on this notebook. Please find time to just try. So my hope is now at least try to understand how do you handle missing value? Just theoretically, you have mentioned, you identify them. You can either now drop them or you can fill them. Please find time and identify what do we mean by data transformation? What do we mean by feature engineering? What is data wrangling and data aggregation? So I think I have another question from, yes, at this point, you're able to apply as a data engineer. That's a very good question from observation from Martin. But what I can mention is that if you go to some companies, they have some tools that they use for their data engineering process. So in Python, this is how they do it in Python. So let me just say data engineering tools. But most of the time, this is what they do. So you see, as a data engineer, you can either work with Python. Some people work data engineering with SQL. I want you to imagine you are getting data from a database, okay? And then there are those people work with tools like Apache Spark, especially when you are actually engineering big data. Okay, this is not a very big data, I hope you can see, but if you now in a situation whereby you are dealing with big data, you'd be forced to use some tools like Apache Spark, Apache Kafka, which is actually a tool that can actually give you real-time data streaming and so on and so forth. Okay. Now, I can even say that confidently you can apply as a data engineer. Yeah, that's true at this point, because you know what data engineer do. Yeah, so Noah, yes, you'll get a recording exactly after this class. You'll be getting a recording for the same after this class. So we've recorded all the sessions. So we are going to export it and provide it on our YouTube channel. And also you'll find it on this Jenga e-learning platform. So with that one, no more question. I can see we don't have any question up to there. So I wish to stop there for today. Let's meet tomorrow. Not tomorrow, sorry, next week. We now proceed with data visualization using Matplotlib. But before we do that one, we are going to clarify on how do you handle missing value in more details, how do you perform data transformation in more details, and how to perform feature engineering in more details as well. So with that one, have a good night, and let's meet next week on Monday. So have a good weekend, and bye-bye.